Greetings, math friends. I'm going to solve this system of nonlinear equations. These are both quadratics, so we have some U-shaped curves, parabolas, that are going to intersect each other. There's only a finite way that that's going to happen. You could have 1 point of intersection, 2 points of intersection, 4 points of intersection, infinitely many, or no intersections. So those are estimates about what kind of solutions that we're going to have. I'm going to substitute the x equation into the y equation everywhere that I see an x. I'm going to rewrite that, then I'm going to simplify, and then I want to move everything to one side so that I have a polynomial equal to 0. So following through with that plan, I have taken this portion of the equation, and since this is x, I plug it in everywhere that I see x. So I took that x out, plugged this in. That first part is squared. The second part is scaled by 9/2, and then we have the 2 on the end. I need to do my distribution here and single distribution here to simplify that, so I'm just going to work through those steps. All right, that goes out a while, but now I'm going to collect like terms to help simplify that. All right, after correcting a few mistakes that I had in here, I finally get this simplified to this equation. Now I'm going to bring the y over to this side so that I have a polynomial equal to 0. So I'm subtracting 1y from this term here. I was able to get y equal to this, and then working my way of bringing the y to the other side, we get that this quadratic equation is equal to 0. We don't have a constant here, it's 0. And we really like to have these constants there because we take factors of that constant to divide into this to find factors of it. Since we don't have that, we're going to have to take a different strategy. One of my go-to strategies, regardless of if I have a constant here other than 0 or not, is I use synthetic division to divide into this to try to find the factors that break this. So I'm going to use that strategy anyways. I'm going to look for nice terms to try to divide into here and see what happens. We have even numbers in our denominators, so perhaps starting with like a 2 or a -2 might be the way to go on this. Quick review as we go into synthetic division. We have to have a coefficient for each term in our equation. It's a quadratic, so we have to have 5 terms: 4th power, 3rd power, 2nd power, 1st power, 0 power. These are the coefficients that are in front of each of the y variables in decreasing order of their exponents. We're going to try to divide 2 into this. We are always adding inside here and multiplying on the outside. So let's make a run through this. Our goal, hopefully, is to have 0 at the end. That means that this is going to be a factor. X minus 2 would be the factor. 2 would be the root. So 1 plus nothing is 1. 2 times 1 is 2. Remember, we're adding in here. Probably would have been better if I had reduced this fraction here. So let's do that. So 9/2 here, and then we're going to have 4 halves here, so we're going to get negative 5 halves here. 2 times negative 5 halves is negative 5. That works out very nicely. That one's not going to reduce for us. So we have 16, that's 3, so 80. A negative again, 55 sixteenths. This would be negative 55 eighths. 0. 2 times 0 is 0 and 0. So that works out for us. We've got 2 zeros at the end. That is absolutely fine. These first 4 terms are the terms that we're going to look at next to try to divide into. Now that we've divided the 2 out, this is known as the depressed polynomial. I tell my students it's depressed because it lost an x. A lot of times when we do these problems, the variable is x. In our case, it's a y. It's lost a y. So I'm inserting y's with powers that's 1 power less than we started with. We started with a quadratic equation, so we're going to end with a cubic equation. So this is y to the 3rd power with a 1 coefficient. This is the coefficient of y squared. This is coefficient of y to the 1st power. This is y to the 0 power, but 0 times anything is 0 here. So I don't really have to write the 0. And then that's all going to be equal to 0. As you look at this, you're going to see that if I put in 0 for y, this whole thing on the left-hand side goes to 0. 0 equal to 0 is a true statement. So 0 is another root to the original quadratic equation that we started with. So 2 and 0 are both going to be roots. But we need more than that. We need all 4 of the roots or the factors, however you want to look at it, which parts you're looking for. So we're going to work with this depressed polynomial, and I'm going to factor out the y. That y that we factor out, that's going to be the 0 solution. When we do this, we have 2 factors here, the y and this quadratic. Having a quadratic here is very nice because that means we could use Sridhar-Acharya's formula, or the quadratic formula as some may know it. So we're just going to make a note over to the side that y is equal to 0 here. Right, we already know that this is part of the solution that we're looking for. So now we're going to focus on this, and we're going to take these terms, the a, the b, and the c here, we're going to put it in Sridhar-Acharya's formula. Many of you memorize this with x out here. This is going to be y because that is the variable in the problem that we are working on. This term is related to whatever you're actually working on. It's not always x. Now that we have this written out, we need to simplify that. Some of you also may question why I don't have any signs on here. This is supposed to be a negative b value. It was already negative, so a negative times a negative is a positive. That's why I have that value out there. This is turning out very nice. We have a 4 from the formula that's multiplying this fraction. The denominator is factorable into two 4s, so those 4s are going to cancel. This, when we square it, also gives us a denominator of 4, so those are going to be fractions with common denominators, so no need to do anything extra on that. This is going to divide out nicely, but the square root is going to be irrational, so that's just something we have to deal with on this. From this point, we're going to split this into two values. I'm going to call this y sub 3 because we've already found two other y's. This is going to be 5/4 plus the square root of 5, and then y4 is going to be 5/4 minus the square root of 5. So we found our 4 y values. We need to substitute each of those 4 y values in for one of the equations to solve for x on each of those 4. Using my second equation in the system, I'm going to substitute each of the y's that we found in here to find the successive x values. The x and y combinations are the points that are the solutions to our system. As we run through the numbers and simplify, we see that x sub 1 is going to be 0. We plug 2 in for this, which means that we have the point 0, 2 as a solution for our system. And that's the way that it's going to run through. We had 4 y values. We need to determine 4 x values for a total of 4 intersections in our system. The next calculation is really simple. We found that our second y value is 0. The first two terms cancel out, leaving us only the half. So x is a half and y is 0, our second intersection. The next point is a little more involved as we have irrational numbers in here. You have to double distribution here, single distribution here, run those numbers out, simplify, and I get a number that looks like this, and I'm going to keep it like this for exactness, but you certainly could put this in a calculator and do an approximation. And the fourth one is going to be very similar to it because we just have a change of sign in here. Our x to the fourth is going to be the same value you got for x to the third, except for a sign swap. Even though this looks like a simple sign swap, the sign swap occurred here. You run through the numbers, and it ends up that this number and this number are a sign swap themselves. So that takes us back to putting this all together. We see our original statement, we're solving this system. There's a lot of work that we did here, and ultimately right here are the solutions. These 4 points are the intersection of these two parabolas. There is a lot of work in this, hard work, and a lot of work doesn't mean that you're doing something wrong or that you can't do math. It just sometimes there's a lot of work involved. Hopefully you find some mathematics in your part of the world to share with others and enjoy. Cheerful Calculations.